So here we go. We have the surface area of a sphere, and then we're going to talk about the surface area of a hemisphere. Now, again, I told you a few minutes ago that this is kind of one of the shapes that I just say you have to memorize. All right, because it's just not something that's easy. Like finding the surface area of a pyramid was easy to figure out that formula. The surface area of a prism was kind of easy to figure out that surface area, but there's no way for you to figure out what the formula is, so that's something you're going to have to remember. All right, and we say that, and I want you to write this at the top, surface area of a sphere. Now, normally what I like to do is I just like to make the subscript like to look like a ball. So the surface area of a sphere is 4 pi r squared. 4 pi r squared. So it's kind of like the area of the circle, except you multiply the area of the circle by what? 4. That's all there is to it. All right, that's the formula for surface area of a sphere. 4 pi r squared. All right. Well, we don't call it a semicircle. We call it a hemisphere. All right, a hemisphere. Semicircle would be 2-dimensional. All right, 2-dimensional. Now, I want you to go ahead and say that again. What do you think the surface area of a hemisphere again is going to be, Nathan?
2 times 5 radius of 7.
Why do you think it's 2 pi r squared?
Because it's half of the sphere.
Right, so if I do this down here, kind of try to draw that. Everybody thinks that the surface area is 2 pi r squared. That's what everybody thinks. And the reason why they think that is because they just look at it and say, well, a hemisphere is just what? Half. But what I want you to do is I want to look down here and I want you to tell me why it's not half.
Because there's the piece.
Yes, so what happens is, she's exactly right. If you were to cut a ball in half, right, if you cut the ball in half, right now there is no side. But all of a sudden, hey, guys, stop doing your calculator. Put your calculators down. I'm not interested in getting anything done. All I'm asking you to do is watch the introduction, and in a minute I'm going to get you started. I'm going to say it's an easy day. Just finish this up. All right, that's all we're doing. All right, simple day. All right, but I'm trying to get you to understand why, Nathan, that the hemisphere, the surface area is not pi r squared. All right, or 2 pi r squared. And she just said, well, if you slice it, then what happens is it creates this right there. And that becomes part of the surface of the hemisphere. All right? So, can anybody tell me what they think that the surface area formula would be? What do you think? What's the area of the base? Yes, it would be. That's exactly correct. So this right here, that area is, again, what? Yes, that area would be pi r squared. So what would be the technical formula for the surface area of a hemisphere? What?
Pi r squared times 2. No, wait.
Anybody else? Come on, think about it. Times 3, why?
Because, well, I just thought because the outside of each.
That's actually correct. All right, and let me try to explain this. All right, so I want everybody to look over to the first example, this right here. So if I were to draw, or you're supposed to, which is very difficult, is that's a 3-dimensional ball, correct? So if I were to paint that, all right, you would tell me that that surface area would be surface area is 4 pi r squared. Is everybody with me on this? Just listen to me. Does everybody agree that's the surface area? 4 pi r squared, right? Then what I'm going to do is I'm going to come in here and I'm now going to cut it in half. Right? So I'm going to take this and I'm going to make this bigger so you can see. I'm going to take this right here and I just cut it in half. Does everybody see that? Hold on a second. So I just cut it in half. Does everybody see that? Right? So what did I do to the surface area? I just cut it in half. So now instead of it being 4 pi r squared, it's what? Instead of it being 4 pi r squared, the surface area down here is now what? That's right. We would say it's 2 pi r squared, correct? But when I sliced it, I created another surface. This right here is the new surface. Does everybody agree that was not there previously? Is everybody hearing me? That was not there previously. Right, but what is that shape that was created when you sliced it? A circle. So do you agree that created a new surface? And the area of that surface is going to be what? What's the area of that circle going to be? Pi r squared. Come on now. So then the surface area is going to be what? No, the surface area is going to be what? Yes, 3 pi r squared. The reason why it's 3 pi r squared because now when you cut it in half it was what? 2 pi r squared plus you're going to add another what? Pi r squared because there was another surface created when you sliced it. Alright, so the surface area of the hemisphere is what? Surface area of the hemisphere is not 2, but what? 3 pi r squared. Surface area of hemisphere is equal to 3 pi r squared. Alright, it's equal to 3 pi r squared. Does anybody have any questions? Now again, I'm telling you, each time, every single time, I want the formula written, I want the substitution, and then I want the multiplication. Alright? So, for example, number 1, just to make sure everybody's with me. Alright, I'm going to come back over here. And I'm going to grab all this right here and move it away. Alright, and I want everybody, tell me the surface area formula again. Surface area, I'm listening. 4 pi r squared. And what is the radius in this case? 9. So surface area equals 4 pi times 9 squared. And then you put the approximately. 4 pi times 9 squared. Say it again. Then you have to give me units.
Inches cubed.
Don't repeat information. Tell me what you think it is. Right, inches squared. So you're just repeating information. All right, think for yourself. Inches squared. Inches cubed is measuring what again? Volume. Inches cubed is measuring volume. We're measuring area. You always measure area with squares. So again, double check with your calculator, please. 4 times pi times 9 squared. Anybody have an issue? Anybody have an issue? Okay, so now over here, all right, I want everybody to write down surface area equals, all right, say it again, 3 pi r squared. Surface area equals 3 pi, what's the radius? 15 squared equals, someone.
2,120.58. Yeah.
And then we would say what? Yards squared. So we agree that's simple, right? Now please, right now, you're double checking with your calculator. Double checking. Harrison, you good on that? All right. Anybody have an issue? You good? All right, here we go. Everybody now, you are on your own. All right, I want you to finish up the first page and the what? And the back page. All right, every single time you're writing the what? Formula. Then you plug the number into the formula. Then you tell me the approximation. All right, get to work. No more talking, especially out of you. No, sit, be quiet. No, you're not working together.
I'm